Hey, what's up, ladies and gentlemen? We are going to talk about everybody's favorite solving exponential equations today. This is super important, actually. Um, yeah, I don't know how to say it. It's super duper important. It's not super important if you want to like make Wheaties on the not on the breakfast. What am I saying? On the in the morning. Duh. It's not important for regular everyday type of stuff. But someday you guys are going to take this wonderful class, and not all of you, right? Some of you guys are going to give up on math like the moment you graduate high school. But for the rest of us who kind of enjoy math, who went to college for it and got a degree in it and, all that stuff, someday you're going to take this sweet class called differential equations. And then you're going to learn this really cool secret. Did you know that you can write y equals mx plus b as an exponent, as an exponential? It's pretty rad. You can write almost anything as an exponential. Like you can write sine waves. This is the crazy one, right? If you have something that looks like this, right, you can write it as exponentials, which are made of things that look like this. So how you get this thingy out of this thingy, you'd have to be Euler to figure that out. But my point is, if you ever want to do anything useful with math, like you want to get a job where you make stuff, I don't mean you just put it together, right? I mean you sit down at a desk and you design something, and then they make a million of them and then put them in something else, and then people go, wow, that's incredible, I wonder how they even made that. It's math, dog. So this is something that you're going to want to remember for the rest of your life, unless you hate math, in which case you can forget it after you graduate, but c'est la vie. All right, let's get into it. Here are your properties of logs. These are just here from last lesson, but I don't think we're going to be using them. I put them here as a precaution because sometimes you need to know your properties of logs. I didn't teach you this just so that it could go away. So these will come back, but I don't think it's necessary for you to have them right off the top of your head today. What you do need to know right off the top of your head today is the definition of a logarithm, and you need to know how to take an exponential equation and turn it into a logarithmic equation. So let's go over that really quickly. You are going to have an exponential equation, and what we mean by exponential is you have some number and you have the variable in the exponent. That's what makes an exponential equation. You can rewrite this as a log, and it sort of reframes the question in a way that makes it solvable for us today. So let's just go over how do I turn this thing into this thing, and then we'll call it good. So let's make up like a nice example. Let's do 2 to the power of x equals y. If I want to rewrite this thing as a log, obviously you have to just pull a log out of nowhere. So just write down the word log. Now this little tiny b here, let's go look over here and find the b. Oh, it's your base. So the word for that thing that has the exponent on it, this thing is called a base. It becomes the base of your logarithm. Both are called bases. Okay. Inside the logarithm, where this y here is, this thing is called the argument. And it's not like those things that you have with your mom on the weekends because she caught you sneaking out. When we say argument here, we mean thingy we're plugging in. It's kind of like a mathy term or like a computery term, but you're doing math, so let's be surprised, right? So the place we get the argument from is it's whatever is on the other side of the equal sign from the exponential part. So this part over here that doesn't have the variable in the exponent, that becomes our argument. So we put the y in there. And then this thing that the logarithm is equal to is whatever your exponent was originally. So this is going to equal x. If our exponent, let's pretend it were like 3x, then this would be 3x. You take that whole thing, it's not just the variable. If it were 3x plus 1, it would be 3x plus 1 over here. So the entire exponent is what your log is equal to. All right, now that you're masters of that, let's go do some examples. Just kidding, we're not gonna do examples. I'm gonna teach you steps. Because I understand that not everyone likes to sit and chew on math all day. So I think that you find it helpful to have a set of steps to follow. So the very first step you want to do is you want to isolate the exponential term. So if you have something like 2 times 6 to the power of 8x equals 5, the exponential term here is the base and its exponent. So this thing needs to be by itself. It is illegal to multiply that 2 to that 6. You can't do that. If you do that, the math police come to your house and then, wow, that got dark really quick. We're not going to make that metaphor. But it's illegal. You can't do that. So what you're going to do instead is you're just going to isolate it. So 2 times 6 to the 3x equals 5. This thingy is our exponential. So we need to get rid of this times 2. So you divide both sides by 2. 6 to the 3x equals 2.5. There you go. That's how you would isolate that. Okay. You're going to go, but Barton, we get this ugly fraction decimal thing here. C'est la vie, kid. It's math. You got to deal with fractions and decimals someday. So you might as well just deal with it. Okay. The next thing we're going to do after we isolate our exponential, then it is ready to rewrite the equation as a logarithm. You're just doing this process right here. Let's make that nice and illegible for everybody. You're just going to rewrite it as a log. At that point, you're going to have like log base 5 of 12 equals some stuff. Now you need to simplify the log with a calculator. So this thingy, I checked your homework. It looks like this thing will almost never simplify to something nice. You will get a decimal 99.99 repeating forever % of the time when you do these. So this thing, you just beat that thing to death with a calculator. On your calculators, there's a button. If you're in the calculator section, and this is assuming you're using the Casio G2 FX9, whatever the thing is called. It's the one you checked out for my class. When you're in the calculator section, there's a bunch of little soft keys at the bottom. I mean, there's like little options on the screen, and one of them says math, I think. If you press that button, there's another option you'll see, and it'll say something like log AB. That'll make it really easy for you to type in the base. Otherwise you have to know some like other weird tricks to do it. But you need to figure out how to type this thing into the calculator. You could use Desmos, I think. That would also work. All right. So once you throw this thing into the meat grinder, and it spits out 2.1873126 ... equals stuff. Then you just solve for the variable. So this stuff over here, this is gonna be like x plus 3. So you just subtract 3 on both sides, and then you use a calculator and you're home free and you're done. Cool? All right. For all of you that said cool, we're gonna go look at an example. For all of you that said not cool, rewind the video and watch it again. All right, example number 1. We're going to solve this logarithmic equation for x. So we want to know x to what power doubled equals 48, right? And there's not a nice answer to this. If we investigate this question real quick, whoops, that's not the right 8. Hold on, it said 8. So 8 to the power of 1 is 8. 8 squared is 64, and then 8 to the power of 3 is bigger than I care to figure out. But 8 to the power of 0 is 1. So we can see we go from 1, skip way up there, and then 48 is not a nice number here. I don't see 48, which tells me that this x right here is going to be a really terrible, ugly decimal. This x decimal is going to look like your ex after they cheat on you and they like tell you that they never actually liked you and they were just using you for your car and because you buy them Dutch Bros all the time. That's what that x is going to look like. But let's go find it just so you can see it with your own eyes, right? So step 1 is isolate the exponential. In this question, our exponential, the base and its exponent are already by themselves. We don't have a like times 2 out here or a plus 3. So as long as you have a base with an exponent and that's the only thing on this side of the equal sign, then it's isolated and step 1 is done for us. Now we need to rewrite the equation as a log. So log, the little subscript for our logarithm is the base of the exponential, so it's going to be 8. The argument of our log is whatever the exponential is equal to, so 48. And it equals whatever your exponent is, so 2x. And now you're done with that step. You've rewritten it as a logarithm. Okay. Now at this point, we have to figure out what is log base 8 of 48. And that's not something that you want to try and do by hand. So you just use a calculator. Calculator that thing. And when I say calculator, I just mean a thing that does math for you. If you don't have a calculator, you can just Google online calculator, and there's 10 trillion of them. So I've already found this number for us. It is 1.861654 ... And it keeps going. It's irrational, I think. I'm pretty sure it is, probably. So this thing just goes forever. The way you tell where to round at is you look at the question on your homework and it tells you. Cool. So equals 2x, but unfortunately we're not looking for 2x. We want to know what's x. So at this point you're pretty much home free, just divide by 2. And if I were super duper prepared, I would have already put this in the calculator also. But instead, I'm going to just ramble on while I type this in. It's going to be super professional. You're going to totally love it. We might take a side tour, check out some other numbers, you know. But in the end, we're going to end up at 0.930827 equals x. And of course, this is rounded, but you're rounding decimals anyway, so c'est la vie. Cool. So there you go. There's your first example. All right, let's go do another one. All right, so we have 12 to the x minus 3 equals 100. So step 1 of isolate the exponential here, this is already done. You're going to say, but Barton, we have a little minus 3 right there. It's part of the exponent though. So this whole exponent is on this base. That's one exponential thingy. So again, we don't have like a times -6 or a +2 not in the exponent. So we don't need to worry about that minus 3. This is isolated and we're good to go. So now we're going to rewrite this thing as a log. So log, our base is the base of the exponential. Our argument is whatever the exponential equals. And logarithms equal the exponent. So x minus 3. Now you type this thing into a calculator. This one is 1.8532. And this is still x minus 3. And now all we have to do is solve for x. So we add 3 on both sides. And we get x equals 4.18. Whoops, not 18. Excuse me. Back up, back up. Be careful, Barton. 4.8532. That's our answer. Cool? Not too bad? Cool. You'll live. All right, last one. This is one. This is just like the hardest one I could think to make up because sometimes you guys complain that I don't give you hard enough problems. You say things like, "I know you worked really hard on those notes, Mr. Barton, but in the end, they weren't like our homework problems. The homework problems are so much harder." So here's just a hard one with all the marbles, you know. So we have -2 times 5 to the 3x plus 1 equals -62. All right. So our exponential piece is this, the 5 with the exponent. This -2 needs to be moved because this needs to be isolated. So now we actually have to do step 1. So to get rid of this times -2, we just do the inverse. So divide by -2 on both sides. Those cancel. So we have 5 to the 3x plus 1 power equals 31. Now we rewrite this as a logarithm. So we have log base 5 of 31 equals 3x plus 1. This log gets thrown into the calculator because you don't want to do it by hand. You actually have to like look it up in a book if you want to do it by hand. It's tedious. You don't want it. So this is 2.133656. Of course, ... right? It keeps going. It's not exactly that. I'm rounding a little bit, but okay. Equals 3x plus 1. And now we just solve for x. So we're going to subtract 1 on both sides. So this is 1.133656 equals 3x. And then we divide both sides by 3. And again, would you guys like to hear a story? I'm going to tell you a really short story. Once upon a time, there was a math teacher who didn't calculate the answer beforehand, so then he had to make up something to fill time so that he could figure out that the answer was 0.37789 rounding equals x. The end. And then he won an Academy Award for his acting, and now he's rich and famous, and he doesn't have to go to work anymore. But unfortunately, this story is a work of fiction. So until then, don't forget to like, comment, and subscribe. Mash that mother heckin' like button, and let me know if you have any questions.